Hi, everybody. I'm Janet Peng from AT&T. I'm with the Network Architecture and Cloud Division. So I'm responsible for a team that is charged to transform AT&T from the traditional, monolithic hardware to move into open and white box initiative. So let me see a raise of hand, like anybody from service provider. Okay, Sai, and equipment, I know Jeff, supplier, and I know Margaret. So thanks for coming. So I thought that, so what I'm going to cover today is that, why we get into this white box Southside gateway router that Jeff and, company have been talking about. And we'll cover, why open and why flexible. How do we go about doing the coming up with the spec? So AT&T is contributing to OCP the Southside Gateway Router spec, and I thought it would be interesting to share some of our journey and our learning, how we go about, coming up with the spec that not only that it will benefit AT&T, but to the community at large. And then we'll go over a little bit on the cell site, topology, how it's deployed at AT&T and where it is, in the network, AT&T network architecture. And the deployment environment, I'll go into the requirement about for the physical and the environment that we have to deploy the router in. And we'll highlight some of the major requirements. We already submitted the detailed spec, and it is already just posted on the OCP Wiki website on the Telco. So I welcome you to go up there and download it. But I'll highlight some of the major requirements that we have to care for. And then we'll get into the high-level system, what are some major subcomponents that we need on this Southside router. And last but not least, I thought that I will summarize some of the lesson learned and, what we thought that, anybody that wants to embark on this journey may have to, go for. It's just, a few tips that what we have gone through and learned from, and, from each of you, welcome everybody, input. So we have quite a bit of time, and the audience is small, so I encourage that, to make this interactive, okay? So as you have, by this time that you come to this session, that with the push-up, nothing new here, right? Like the exponential data traffic growth, not just because of 5G, but everything else, right? Even the existing 3G, 4G, you see that this exponential growth and the existing hardware, even without 5G, we need to upgrade the hardware even to support the existing technology, right? But with 5G, it requires even more, give us more drive to the need to upgrade the hardware, but on top of that, the 5G requirements are even more stringent in terms of performance, right? That to meet the latency, the current Southside router just does not meet it. You also need the speed and the bandwidth that would be needed to go with 5G. Then. To go into what? Bare metal. Oh, bare metal. Yes. I think that you sit in the Nokia talk, right? Like where they do this open edge, the server, etc. So although you do all this virtualized, cloud, CRAN, etc., you just cannot use today the the typical server. And so a lot of the virtual EPC, etc., their requirement is they are driving SRIOV, like, bare metal. You can't just go through the typical virtualization. Even DPDK, does not help it. And the other thing is because of the speed, like even on the radio access equipment that's changing, now there's like 10 gig, 25 gig. So your backhaul, need to go up in scale in the order of magnitude, right? So typically today, most of the backhaul, you have it like 1 gig or 10 gig. And now with this new cell site router, you can support up to 100 gig backhaul. So those are, and the approach that we choose to do is like, well, we could just do our business as usual way to upgrade the router, choosing today the proprietary monolithic, hardware, software, all integrated from, one supplier. But we choose to go open and flexible and work with the community to build the our next generation router, not just on the south side gateway router. This is just one of the many use cases that we are doing. This is the AT&T vision to deploy and transform our network to be more open and flexible. And we adopt all the open standard stuff. So we try to use readily off-the-shelf merchant silicon that's available that can meet the need, as well as the off-the-shelf CPU like the x86 and modular things like the BMC, etc. So that we give the flexibility to the customer or the service provider to have the flexibility to pick and choose the software that will meet their business need as well as their operational need, right? So they can build the software, in-house or third-party, or leverage the open source and do a combination, of both. So what does open platform mean? It does not mean that it's custom built, right? The idea is that we try to make it modular, so that, as I said, you just have the hardware, and this is what we're talking about. What AT&T is contributing is the specification for the hardware, right? Keeping in mind, and then with the firmware, so you all disaggregate it. And then on top of it, for the open network environment, we all use open stuff like the installation. We use the ONI, which is also available, it's open. And the in the open network, environment, top of it, the plan is to leverage ONAP and OpenStack so that you can do and orchestrate and manage the hardware down top. But so that will encourage us to get this ecosystem of all the way down from the bare metal hardware all the way up to the software, which you can just sort of like have all the Lego pieces and put them together. And it could be doing it this way, it could be multi-vendor source, right? Our idea is that we don't just limit to work with just one supplier for hardware or for software. You have the flexibility to pick and work with, once we put the spec out there, we encourage, folks that have the resources and the talent to build the hardware to meet the spec. And not only that, it will benefit AT&T, but everybody, in the community can leverage it and use it, to suit your environment.
So are you nurturing the alternative methods, an alternative to Intel, an alternative to Qualcomm?
Are we? Well, yes. So Well, so I think that if you said in one of Jeff's talk earlier, so right now I'll get into that a little bit, what component that we select to meet this use case. And, it turns out that for now, that is, but we are not limited to, because the spec is written such that, what are the speed and what are the feature and component that are needed. We did not say that it must be this supplier or this, for this component or that component. So I think, in that way, as long as the ODM, supplier can build to the spec, I really, like, as a end user, I really wouldn't care whether you use, like, part from company A or company B, right? So I'll get into that, how we set up the requirement framework and how we gather requirement in order to meet that, end goal. Okay, so this is the so how do you go about coming up with the requirement, and what do you need to do to gather the requirement so that it will meet your specific use case. With telco, so we try to instill some discipline. At the beginning, it was not easy because we are so used to just when we have a need, we will meet up with an account manager of this OEM supplier and we'll just express it to them. This is what we need. So we don't have to worry about write the requirement in the level of detail that we have to concern ourselves with, down to a little bit more like the component level. So the way that we go about, as a telco and a service provider, we have a lot of different organizations in this lodge, right? So the way that we go about doing this, when we come up with a requirement framework, so that you can use this framework to develop the spec for one use cases, and hopefully much of the work that you do, you can leverage it for the other use cases with some, modification for the use case specific need. So what we did is that when we first come up, given that, like in the, look at it as a different block, right? Yes, at the end, we do want to come up with a requirement for the cell site router. But what is made up of the requirement? There must be some common components, plus the use case specific component. So that's how we structure it, and we look at it and say, there are like some hardware specs and common system spec, like for example, the physical size, the environment that you want to deploy it in. Is it outdoor? Is it indoor? What kind of compliances that you have to meet? NAP 3 for this, or the some AT&T specific requirement, or some most of the world specific requirement. So we gather them and we organize it in such a way so it becomes kind of like requirement building block, right? Same thing, we took the very interactive approach to develop the requirement. We don't just have the system engineering team just sit there and imagine what the requirement might be, because we go out and talk to the operation team to get their input. Hey, as we transition from this environment to this new open environment, what are your requirements and what do you want to, because we don't want to carry all the baggage, right? We want to, keep our discipline and get the, good requirement, but we want to shut out the stuff that is not applicable. We also start out day one, work with our security team to make sure that in our design, we build it with security in mind and not just like, try to fix it afterward. So for this part of it, we kind of like view that as like, common set of requirement that is sort of like a building block for all the use cases. You should look at it, you don't have to reinvent the wheel. And then on top of that, you might have like different, use cases for like the one that we're talking about today is a Southside Gateway router, but you might have other use cases that's an aggregation router, or you might have another one that is a core router, etc. So those specific use cases will impose some additional requirements, but that would be sort of like, delta. So on top of what you already built, right? So this way, it also helps when you work with the supplier, because then as you drive the design of the hardware, you kind of like build it very modular, okay? Then, it not only that it is efficient, that you can reuse a lot of the existing hardware components, but it really speed up the time to market, right? And it really help out all throughout the development process. And not only that, when you do the certification to make sure that you certify the hardware, you can leverage that, like, look, all this part of the hardware, we had tested out all the interfaces. Another group that needed for another use case, you do not need to redo all the work. Likewise, if you find a problem, of a particular issue in a particular use case, you can communicate and let your peers know that, like, look, hey, watch out, we ran into this. So you can really share and share the learning among the different group and leverage it that way, even within our internal, company, right? Not just like, here we are sharing it, with the community at large, but I already see that, like, the openness, right, within, because typically, sometimes, like, companies organize large like this, very silo, but we are also using this method to drive our, development in a new paradigm. So this is sort of like, the internal. And we also, as part of the requirement development and design conception discussion process, we work with the suppliers like the ODM or the integration supplier, the VAR, the value added reseller, or now they call it the post-production integrator. And we also work with the NOTS supplier, and the NOTS supplier could be like internal. In this case, for the Viata box, we have a AT&T internal software developed. Or you can work with third party, or open source. We work with the ODM, supplier to get their input. So the end result is that when you develop the spec, it's more pragmatic instead of just like very theoretical, right? So sometimes, like, we would specify that, hey, we want this, but we might not have necessarily the perspective of how hard it would take to build that part of the function. And when we get input from the ODM, we'll try to rethink and rework our requirement in such a way that at the end you meet your goal, but you don't write the requirement in such a way that it make it very difficult to implement. So then the end result is that when this is all done, our plan is we'll contribute to OCP. Likewise, we also encourage all the supplier to submit the detailed design to OCP. So we have submitted the detailed spec on OCP. You should check it out. And I believe that the review is coming up, right? And on October 4? Yeah. So if you are interested, my team will walk through the detail of the requirements that we posted up there. Is this October 4, 1 o'clock or something, Eastern? Yeah.
7 p.m. This is the OCP.
Yeah, it's an OCP Telco working session, right? Yeah. So any question, on this? Okay. All right, so just want to give you an idea where where we are deploying the cell site gateway router and where it's situated relative to our topology and then our architecture. So this is a typical. This is on the left-hand side, this is a cell site gateway router. To the left here is all on the cell tower, and it has all the radio access network equipment. So think of it like if you have a end user equipment here, make a phone call, it will go, the signal will go to the tower, and it will come down, it will go to the radio unit, and then they send to the baseband unit. Then it converted to Ethernet and send it to the cell site gateway router. So today, the cell site gateway router that we use support like 1 gig and below, the access to the radio side. And with 5G, etc., we need to up the speed, and not only that, but the performance to make sure that low latency. Then on the backhaul, on the cell site router that send up to the aggregation router, the speed can be supported at 10 gig, 25 gig, or 100 gig. So it's an order of magnitude, more. And for AT&T, we do plan to, we have to upgrade all this cell site, right, that you see all this antenna up there. We have tens of thousands of them. So we plan to do all the upgrade with the white box hardware. Yes. For the CPREG on the cell site gateway, I don't know about that. Our RAN team, is working that. I know that they are doing a lot of virtualization there as well. Like, they're gonna go with the virtualize. I don't know if you said on the Nokia talk, right? So they are working on that. I mean, it's not gonna happen like overnight, but today they have to look at that. I don't know. Are you guys doing that? Yes? Yes, actually, it is deployed, in pair. Yes, so we do have the redundancy. Yeah. Oh, really? Okay.
But, your cell site gateway is your switch.
Yeah.
So if you do this other discussion, if you need a second server for that?
Well, that's why they have to look at all this, virtualized stuff. Yes.
Yeah, so then you have this server, and then on top of that, you still have this gateway switch separate. Right?
Yes. Yeah. So, so then connected to the.
You would have the support to CPREG, right? That's probably not supported in your site, right?
Right. Yeah, that would be the additional requirement. I mean, we didn't.
Very stringent
Yes, we didn't get that. Right now the cell site router does not support that at all. If that, we'll have to look at that. Would be coming from our RAN radio access, equipment team, right? And as Sumitra said, they have very specialized equipment. Actually, to support 5G, right? We find out that like this equipment, the requirements are very stringent in terms of performance and all this timing, and that's why I'll go over one of the major, have to support the 1588 V2 timing, synchronous Ethernet, etc., so that it can do auto correction. And as part of that, it will support the boundary clock, etc., so you can do as a backup clock with some holdover. If you lost your primary clock source. It's really interesting, stuff. A lot of stuff to. Yeah, yes, it is, and actually, you see that the density and the number of ports that this box can supply. I mean, it's a very tiny box, and it's actually smaller than the standard 1RU because we needed the depth is shallow, a little bit more shallow because it's an outdoor cabinet. It doesn't fit.
Yeah. Wait, the CSGR is in an outdoor cabinet, right?
It is, yeah. I think I have it. Yeah. Okay. So I went and I went to the south side in Middletown and I took a picture. Okay, because I thought that it's interesting. At least for me, I have not I use the cell phone and all that stuff. I drove by and I just see the tower, so they let me in, and it is locked. So this is a south side cabinet in next to our labs in Middletown, New Jersey, and you can see that this is a south side tower. What I'm trying to say is that you have a very stringent requirement. It's outdoor. It's a sealed cabinet, and the cabinet is not big. I didn't take a picture of the back of the cabinet, but unlike if you have it indoor in data center or central office where you have opening in the back, right? This one, no, it's an enclosed cabinet. So. And that's one of the reasons that why when you read out detailed spec, the requirement, everything has to be front access. The power supply has to be in the front. Everything put in the front. That is the reason. And the other thing that I find that's very interesting is I went into the south side location. It's like a cage, right? So you have different carrier. So I took a picture of this one as AT&T, but then you have another one that's another service provider. It's sort of like next to you. That was news to me. Like I didn't realize. I thought that like when you go to a south side location, it just that's it. And I guess you lease this kind of cabinet or equipment. But for folks that like me work in the labs, I don't really, get to see this. So it was interesting to take a trip with the field engineer to actually see how the stuff that we build fit into this. And actually, I really encourage folks to do that because. Otherwise, you sit in the lab and you just imagine. When you do the design, you really need to worry about this and take this kind of thing into consideration, right? For accessibility, usability, okay? The other thing that we will point out is that as you read the spec, there's a section that we actually even specify the recommendation for the silk screen, like how you label the port, the size, and the contrast of this stuff. Because when we get that piece of equipment in the lab, depending on your lighting, well, I don't know about you, okay? Without a pair of reading glasses, I cannot read anything. I mean, even when there's some of this is very challenging because this is a small box, and you have like on the backs like 28 port. So there's only so much you can do, in terms of put the silk screen for the size. But you should be aware of this kind of thing, right? And you try everything that you can to make sure that the contrast, okay? If a box is black, don't put gray or something like that. So
So that's what I was asking. So if you do this virtualization on the south side, and then of course you're doing this, whatever Broadcom switch, black and white switch, since you have a confined space, right?
yes.
You need to make sure you have enough space for all these pieces versus.
Oh yes. So exactly. So for this cabinet, they did open and show it to us. So this router just had one, and then another piece of it. It was the the baseband unit, the RU, the BU, and and something else. That's So it's very confined, right? And when we.
Do you have all the different, CRAN or what do you want to call this, virtual LAN, specs to know know that when you do your gateway, it all.
Yes. We talked with, like, in the previous other slide that I was telling you, that the use case or the specific thing, we make sure that we work with the service design team, and they are responsible to pull in the RAN team to give us requirement on, like, timing, what kind of timing function. And on this box that you will see, we have a lot of, like, more than usual in terms of the input and output timing. Well, because 5G is not going to be here tomorrow, so we have to upgrade the equipment, and it has to interwork with and support all the existing legacy stuff, right? Even the RAN stuff upgrade, you have to interwork. So we have all, given that, like, we're a telco company, and you do want to, it's not a green field, it's a brown field, okay? So you want to design, you take careful consideration and talk with the responsible group, because we are very conscientious about not to carry all the baggage. We want to carry some, but make sure that it's on the carry on and not like, I don't want to check in, okay?
Is your requirements like SIAD, the requirements for this smaller than a SIAD, or?
This is a SIAD. Oh, then the physical is the same. It has to be identical because it has to fit into this existing cabinet.
But I was asking that when you start doing all the virtualization, if it doesn't exist today, then they might need more space. I don't know this.
Well, that's why the talk. Okay, so I don't know if you visit the. That's why right now the innovation, the talk and the thinking about, like, to do this virtual. What is it, open edge, and you can even mount it on, I don't know, on the tower or stuff, because, right, this cabinet is limited in space, okay? So
Oh, I see. So that's kind of
alternative, like that outside, and then so it just run cable, right? And that one, the open edge that was, I think, shown on one of the booths, it's even like, it meet all the outdoor temperature requirement, etc., right?
Might be able to help you with this question, because now is the migration period. They are trying to upgrade
Yes.
the infrastructure, so they use existing installment, same cabinet, fit in the new
Yes.
sales side gateway, and some of the virtualization servers. So the requirement we got will be able to fit existing. But they are already preparing new cabinet for
Yes.
installation for a new tower or for new.
New yes.
But there's a new stuff, totally.
That would be brand new, right. And then for that, right, it would, like, the same, cell site router, it would fit into that, but you would have to deploy maybe in new location, like this gentleman, what's your name?
Milo.
Oh, Milo, okay.
So Janet, is this where a DU would also be housed?
The DU,
The ORAN architecture they have, DUs, CUs in your centralized, right?
right.
That's virtualized. But DU, I think, is a physical.
I don't know, I don't.
Technology will consider CSR as sales site gateway. And
Yeah.
DU. You still need to have an application unit. Which
Yes.
will be the
S-
and then,
Oh, the cell site gateway is considered a DU?
yes,
Yeah.
at least from our understanding.
So then for the other one, you have to do the backhaul to the aggregation router, yeah.
I thought you would actually have a number of DUs and this would aggregate,
Yes.
Yeah.
right?
For this sales site gateway, it's not only for this tower, it's coming into other.
To other, yes.
So they give you an antenna unit. So you are collecting
All the stuff.
stuff to this sales site gateway. So this should be a DU in this sense, and then we have other CUs at the back. You still have a high level application from the sales site gateway.
Yeah, on our side, it would be like the MSN, the mobility serving node. That's yeah. Okay. All right. So I'm just gonna highlight some major requirements. Like I said, the detailed spec you can download, from the wiki page. It has all the detail. So it needs to be like, redundant, very efficient power supply. It need to have a CPU for the NOS to run the routing software. And we are, because doing this open, and as you know, this is a outdoor and remote site. So, need to take into consideration management and auto recovery. So we choose to go with similar to the data center server type. We use a BMC. And as one of the talk that I participated today, there needs to be some work to get this BMC. Not all the feature and functionalities are there. So for now, in the interim, you might have to use some commercial, BMC software versus just pure open source BMC. But that's an area that we need to work on. And in terms of the Mac, we selected the Broadcom, the DNX family, Qumran chip with a deep buffer to support all the advanced feature, as well as QoS, which is one of the requirements that we have to support. In terms of the interface, this is a very high density, high bandwidth router. It can support. It's a combination. In the spec, it will call out. The way that we write the spec is we write it in a way that is flexible, so that the supplier are not constrained in build this, right? We have some minimum number of port and speed type that we need. However, beyond what is the minimum requirement, you can be flexible. So, for example, one of the, many of this SFP, it can support both 10 gig or 1 gig, okay? We also specify some long reach, like 80 kilometer, 40 kilometer, that sort of thing. And in the spec, you'll find out that we also specify detail, so that we are not necessarily requiring that the supplier have to put a PHY chip there. If your design, you can do it in such a way that it can meet the reach. We are okay with that. And additionally, so this Mac chip can support the 1588 SYNC-E. We also have additional timing circuitry, right, in the design, in order to support the various input and output, timing input and output that we need, that may not be just necessary if you just use the output from the chipset. How do we do? Oh, the hitless upgrade. So with the SIAS deployment, so I think that we have it in pair. So for now, yeah. I mean, this one is just right in terms of we're not changing the architecture, right? This is really like an upgrade of the equipment fitting into the existing architecture. Yeah, we have the yes. So with the BMC, we do have the hour band access. It's built in as future proof, right? Right now, that's not what we have. In terms of, but there's an hour band that you can access in via the BMC. Correct. Right. Correct. Right. Yes. And the,
everything over, or you upgrade one side, you go back,
yeah.
I'm just gonna try to do it when
No, I think that they use the duality, of the switch. So it does not change today's operation. However, we are doing it today. That's support. Yeah. Yes. Yes. Yeah, but as that gentleman said, right? Like with the SIAD, so it can. I think that the way that they design, you don't just go to one, okay? So you go to the other, cell site for the south side router. So your traffic, if one is not available, it will go to the other one. Yes. Yes.
But also the clocking, right? You get to the clocking. One of the problems with the Scion region was clocking was the software, so it wasn't accurate enough, so then it had to use the hardware.
Well, yeah, I mean, right now in each of the cell site, it has the GPS signal, either right on the cell site, if not, or you get it from upstream, like I think that in our case, we have it, we get the clock source from the MSN. Yes, no, not the NOS, right, in the network. So just want to show you that here's some critical major subcomponent on the box. That's what's pointed out. This is the power supply, and this is sort of like the front, okay? The power supply, everything is front access, except for the fan, because there's no room, so you put the fan in the back. So if you have to replace a fan, you actually have to remove the unit and replace it. And this is the various network management, like RJ, the craft management port, like RJ45, USB, micro USB, etc. And here is the different interface that we bring up to the front panel, right, for either supporting 40 gig, 100 gig on the QSFP, or the various 1 gig / 10 gig, 25 gig on the SFP. And this is all the various input and output timing that we have to support for both the existing stuff, and then you have a clock functionality supporting IEEE 1588 and synchronous Ethernet. And this is the sort of like the brain of this Southside router, the Broadcom Qumran AX that has a deep buffer and that can support all this speed. What else? Oh, we have a dual flash. That looking at this picture, Margaret, that reminds me. So the reason that we put the dual flash there is that so when you do the software, upgrade, you can work on it on the other flash so it doesn't interrupt the thing. Yes. And then, the Intel CPU with 4-core. One thing that I want to point out is we do have this I210 that can support DBDK. So this way, this is a mux function. So it has a way to either, if you want to use a fast path to do more DBDK stuff, you get, you have 2 less 10 gig E port in the front. But other than that, so it's designed with this flexibility, but if you don't care for that function, you can just use it, all for the front port facing and not spend the 2 10 gig E to the Intel CPU. Okay? And the airflow is front to back, and the depth of the unit is a little bit shallow. I think it's a little bit short of 12 inches. Otherwise it's a typical 1RU 19 inches unit.
Do you guys have any virtual applications on this?
No. All right. So I thought that, maybe you'd share some, what are some of our experience and lesson learned, in this journey. So we thought that, we made great progress, and we really are on track to deploy our first box, cell-site router this year, right? And so what we find out is that as we get into this, there aren't too many people, so I invite that folks to please join the telco meeting and contribute and talk, because we need the more like-minded people to share the experience, because this is very different. The environment and the requirements are very different than the data center, which you have a lot of contributors. So bring your friends and colleague to join and start the discussion. It's fun. You tell them it is like exciting. At first, it seems like very daunting because you don't know where to begin. Okay, but once you really get into it, and it will happen. I think that it's just a matter of time. It will take time because that right now we don't have as many adopter. So Margaret, please help. The other thing that we learned is that it was really like a nice collab. At least for me personally, I learned a lot just talking with the ODM and the supplier on things that like I don't necessarily concern myself with previously. When you just do like system engineer higher level requirement, it gives you an appreciation of the work and effort that went into it, like right, and it also forces you to, as we write requirement for the boxes, because you know what it takes, right? And sometimes if you just put the requirement and phrase it instead of like dictating the implementation, you express the requirement, say what it is that you are really want, the goal, right? And you leave it like have this interactive, collaborative discussion with the supplier, whether it's component supplier or the design manufacturer. You can come up with a more innovative and cost-effective solution. Versus like that's one thing that I learned and my team learned.
Is there a concept of NAPS compliance?
Yes. Yeah. So one thing that we did there, right? That is an area, an example that where common requirement makes a lot of sense, because once you do it for a class of hardware, it is the same requirement. If it's indoor, if it's for central office, you only have to written it once, okay, and educate or go over it with whoever your ODM suppliers are. Educate them once, right? So they do it. So I find that like whereas previously, the supplier just go off and build the requirement, and sometimes like with some guess that like we think that like that's what you need, and then later on it does not pass. You have to go back and put some filter to make sure that it pass EMI or EMC, blah blah blah, right? That's not the most effective way of doing a design. The other thing that we learned through this process is that all the existing process, much of the existing process that you have today to support the current model does not really work. You really have to come up and create brand new processes and operation model to support. It gives you an opportunity to provide feedback to both the ODM and the component supplier on the feature and stuff that like telco, important to the telco use cases. Another thing that we find that for agile development, software, hardware, for hardware, you really need to have a reasonably stable hardware in the lab, even to do the POC. Okay, you can't just, because once you have that piece of hardware, if you find out something that is not right, okay, you can't just go say, okay, let me just recompile this and I'll give you a different release version next week or tomorrow. So so for hardware, you really want to have a very stable hardware, even for the prototype. What else? So I think that this is a journey, and we started it, and as I said, it's not easy, but it's really very exciting and fun, and it is real. And encourage all to join the telco work group, and let's start to have the dialogue and share our learning, and make this happen faster and sooner. So it seems like you guys are you doing some of this?
Yes, so actually I'm from the supplier side, but I'm looking to figure use cases same as you. I think your point is correct that although there's a use case for the CSG,
Yeah.
trying to find other use cases.
Yes,
So we're gonna
yes,
utilize this
yes,
technology.
yes,
And for the CSG, we are thinking that the unique design that you change the interface for accommodating all these different mode requirements.
oh,
So you have different modules.
yeah. Right. I mean, like for example, right? So in the spec, when you read it, right, we do have some of the optional requirement or feature or requirement for consideration. It's not a requirement for the cell site gateway router, but to the manufacturer or the supplier, if you look at that, like for example, there's one requirement. Dying gas, right? We don't need it. However, but in terms of hardware, when you do the design, if it can come relatively for free, it would be nice, and it does not take up, add too much cost to it. Maybe we want to consider it, or somehow you can do it modular, right? And then so you can have all this like Lego blocks, and for whichever use case can use it, you would just, put the different configuration together. But at least you have those common module. Yes,
System integrator or some post-production integrator.
yes.
What do you see the value of them? Because
The post integrator
it requires a lot of different
coordination.
yes, and domain knowledge actually.
Yes. So I will comment on. So the way that, because it's the disaggregated, open, separate hardware and software. So typically, when they, at least in the state, right, when the box that get imported from country like China, it has to be all free of software. Okay, so all the software need to be loaded, in somewhere in the state. Okay, so right now what we envision the integrator do is that somebody has to do it. Okay, either we ask the ODM, on behalf of some, AT&T do it, or an AT&T, some operation team has to do it. So we choose to go with the integrator. So right now we are working through the process in terms of the scope, what exactly we want them to do. But for sure, the part that we are asking them to do is to load the software, right? But I think to your point, it's more about like post-production support. If you have a problem that, something doesn't work and you don't know if it's hardware, software, what, now that you're disaggregated, right? Previously, you just called up company XYZ, whoever, because they provide both hardware, software. Now, internally, they will have to sort it out to the hardware team or the software team to do the triage. So we are working, through that operation model. So we engage the operation team. So I think that the way that we are thinking is that, look, as you said, this requires domain knowledge, right? So if a problem that is very obvious that is hardware, let's say that the fan died, or when you power it on, nothing happened, then immediately you go to the our post-production integrator, where they have all the parts and spare, unit, etc. But most likely you will have a case where you require you know, 3-4 party to get together and triage. I think that what we're going to do there is that our operation team, the tier 1 operation team, will have to take on that role to kind of like coordinate and call up. I mean, I think that they will probably take a stab at it first to see if they can, figure it out whether this is a software problem, where they will work directly with the NOS supplier, or if this is a hardware, then they reach out to the hardware supplier. But that, yeah, no, we don't think that like this is way too much domain knowledge. And this really, you cannot train them. I mean, you cannot write it in the instruction because every problem is different, okay? This is not something that you can just do a procedure. Yeah. So, comment, question? So are you, Paul, are you guys doing this? I know that you work on this GPON OLT, and I said in your talk today, it's actually a lot of the points and challenge that you point out. I'm with you. Yes, you will have the same. Yes, 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 yeah. But I see that folks are excited because like I was telling my team that if you come in and we have to create new process, new operation model, everything new. You have to think out of the box. If you come in and you don't think that, you know exactly what to do, I think there's something wrong, right? Because then you're not thinking, this new model and this new disaggregated and open. So that's part of the. So I would love to hear your experience and your challenge and how we can work together to push this forward, right? I think that we need more adopter that we can talk to. So anyway, well, thanks for coming. So hopefully this gives you a glimpse of what we have done. And like I said, this is a journey, but like every journey, it starts with the first step. And I think it's exciting. And thanks to the community, I mean, we wouldn't be able to do all this. A lot of the stuff that we use in component ideas, not all our original idea, like BMC, we just take it, data center use it. That's a good idea. And as we do this open disaggregated white box, why not take advantage of what other has done? So we adopted that. I know, yeah. So I have to learn it from you. Yeah, actually, right, I think a lot of work needs to be done there, right? Because we find out that there's a lot of feature and functionality is not there with the open BMC, right?
It's relatively new, so they have to evolve as well. And
yes.
I think the important thing about they want to have this consistently in all their equipment.
Mm-hmm.
Required component, in my view, at the point where you don't have full redundancy as we are used to with our chassis-based.
Yes.
So if you don't have a full redundancy, at least you do have a hook of last resort, a little box that allows you to go, not physically but virtually.
Virtually, yes.
And not to have to send a
technician or a truck roll out there. Yes.
Every business.
Yes.
Set down a network that is down for hours would kill your reputation as well.
Yes.
I discussed the full redundant design. We are doing a 3U design for this cell site gateway. I discussed with a few telcos. They said, why do you want to have this one? Because if you are going to a purely white box, they could use a few different white box to.
Please use the microphone so everybody can hear it. Not just a couple in the room.
It's already completed. So Well, I still don't know if the telcos will consider to use this kind of legacy design with in-box redundancy in this area, or you are going to use purely white box, just one RU design, and maybe create some redundancy in a different way. I don't know about this. Maybe.
Oh. So you mean like if we consider doing the built-in redundancy in the same box?
We have a box. We have two Qumran AX inside. Okay, we have different input, and we took two signals from the antenna radio unit directly, and it's a 50-50 load at the moment.
Oh, I see.
But-
It's more like our uplink. Like you have like dual uplink, but then you go to the two different box. But then in one of the, let's say that one of the link
Yeah.
fail, and you cannot really handle the traffic 100%. So you have to engineer such that.
It could be 100% and 0. It's a hard standby for another module, and then switch it once the packet is some kind of broken or how it's broken. The idea of the white box is get rid of this kind of complex design in the system. That's our point. So we don't know which way the telco will go into the future.
Well, I would say that like whichever way that give us the most cost-effective solution and the best design, that is the way.
Well, open too.
And open, yes,
Because the key is also disaggregation, right?
yes,
Open hardware, open software. And that's kind of why we're pushing on the white box
Yes.
design. So as long as you have open interfaces and you're open to having any software loaded.
But in that design, right, what kind of it's almost like double the cost. I mean, close to double if it's not double. If you just have to now add another max chip, in one unit, and you do this completely hot standby 0 and 100%, no?
Not really. From our point of view, we are able to kind of optimize the design in a certain way. The cost might be a bit higher, but it actually solves some of your issues regarding the maintenance and others. But we are just not sure if this is the direction to go.
Maybe I would have an aspect to add to this discussion, is that me personally, I'm much more concerned about the reliability of the open software part than the reliability of the open hardware part. I do not consider that it's, in most cases, will be useful or necessary to have a fully redundant forwarding hardware or fully redundant uplink. If anyway the fiber is broken, well, there needs to be a repair guy needs to go outside. So this is not a question. But if we have an open firmware in a CI/CD development model, that means we do not do a firmware upgrade of our outdoor equipment every 2 or 3 years, because it's very, very stable, and it was GA tested in a 12 months process. But we want to roll out software, well, maybe every every 4 weeks or something, because we have a minor feature change or even a small security patch. So it will be very often small software changes, and it might turn out that one of these changes will create simply a software crash in the single controller instance in those boxes. So every hardware and every data path would be fully okay, but this thing is crashed, the Linux NOS is crashed, and it will not come back to life if you have not a last resort hook. You can dial in outbound to a BMC, which can in turn go to the serial and force this thing to reboot, force this thing to reinstall, force the thing to get to life again without having to be physically present. So I think this is much higher probability for such kind of failure than the hardware issue.
I agree. Yes. Actually, that is true, right? I mean, this is a challenging area and a lot to be learn, in terms of like this open. I have that concern because every time that in service provider, we take great effort and great care when we certify a release, hardware software combination.
So, there is one thing for the software features of switches. I don't know if you've seen any of the presentations.
Now you need a microphone.
Yes. I don't know if you've seen any of the presentations by some of the hyperscale providers, but they actually have simulators that they put the new software on, and then they run their load through it and verify that that works before they roll out, because they have a higher cadence of software loads in their NOS because of the features that they're wanting to use in their network. And so, it was a shoot and pray before operation, where you'd blow, well, yeah, but you'd blow to the switch and then bad things would happen. And so now they have software that simulate the network and then push the real traffic load towards it to see how that network goes. And they're actually now talking about simulating their entire network of, here's what happens when I load this software. I mean, you need to talk to like the Facebook guys or, in their network group about these capabilities. But, you're certainly, when you move to software and you disaggregate, you then are able to do things and simulate more in software where we didn't have that luxury before.
Sure enough, and I think that's a good approach, but I think the context is not the same. If the Facebook guys, they have dozens of data centers, we'll have thousands of COs. So it's they can, and they have their data centers, there will always be people that can run over there and rip out the server or reboot the server if there's a real issue. We can't run out to thousands of COs at the same time. No way.
Well, I don't know how much you know about their networks, but you might really want to dig into their networks. I mean, I don't know, on the keynote, there was some number of miles of fiber that they run that they broke down into kilometers. And I mean, so, we're talking, maybe they have some coherent optics, maybe some not. But, this is not a trivial network, and it's not a trivial data center, and they're not immune to truck rolls, and it's not like they're staffed 24/7, and they have a much higher server to operator ratio, and not all of those operators are actually, switch operators as well for network.
The interesting thing that they do, which is what the telco guys have got to get to, is that they run a lot of, server capacity, and they can respin those workloads. And that's what we've got to get networking guys to, is to be able to move those workloads. So
I'm not talking about their workloads. I'm talking about the network switches and the outages that they've had and the tools that they've developed to simulate the network to run the load before they put the new firmware onto the switches.
Yes, but when we build a network, we in effect build, single points of failure. We can create diversity, but it costs money. We put the redundancy in it, costs a lot more money to do that. Whereas what the data center guys or the cloud guys have been able to do is they can do an N for one type of protection scheme. So they can run a huge amount of servers and have one server sitting there as a backup and move that work there. How do we do that in a networking
see, but in the networking world, right, you do have this last mile access, right? So how do you, unless I as a customer willing to pay, or the service provider charge me in such a way that you have dual thing, because the minute that you cut it off, you still have to do something. Yeah, you can move it over, but you need to have the planned capacity, and in some cases you can't just like swing it over like a server, like a patch panel. Yes.
Yep. You yank it and it all works still.
Yeah.
We lost that long.
Yes. Right? So Yeah. So we definitely have it's a different space and there's a different environment and different set of challenges and, engineering problem that we need to solve. And unfortunately, we don't have that many, I don't know, what is it, a dozen, big service provider, but we really need to get our head together and try to crack this nut.
Well, then it's not just for the switch, right? I think for the data center and how they do the servers, and what we're trying to do an SDN-enabled, like a broadband access also, which will, where you can have these applications run on x86 server. But again, due to the same reason Jared just mentioned, you just have single point, right?
Yes, the last mile, yes.
And you're not even able to, host it in a different CO, then you have to worry about, how do you switch? And there's it gets more complicated.
Yes.
I think those are definitely some of the challenges we have to work through.
Well, I mean, the analogy is almost like, we provide the transport and like all the highway, okay? So yes, you can get, off, right? But then if the major point get break, and that's it, you have to, unless you have this exit that it go to this or that, you can't, you have to wait for somebody come up here and I don't know, rescue you. But anyway, well, thanks for your time. I hope you guys had a great,